If you get LeetCode problem 238, product of array except self, in a FAANG interview, the absolute biggest trap you can fall into is using the divide trick. It seems incredibly easy. You just multiply all the numbers together, loop through the array, and divide the total product by the current element. But a senior engineer will immediately shut that down. They will ban the division operation entirely, and they want to see if you can still solve it in a linear big O of n time. Today, we are going to master the ultimate prefix and suffix scanning technique that completely bypass division and proves you have elite data structure skill. Let's head to the board and map it together. The problem asks us to return an array where each position contains the product of all the number in the original array except the one at the current index. Look right here at our input, which is 1, 2, 3, 4. For the index 0, we just multiply 2, 3 and 4, which should give us 24. Similarly, for index 1, we multiply 1, 3 and 4, which will give us 12. Similarly, for index 2, we multiply 1, 2 and 4, which will give us 8. For index 3, we multiply 1, 2 and 3, which gives us 6. So our final result is 24, 12, 8, 6. Since we cannot divide, how do we calculate this efficiently? The secret is breaking the total product down into two separate layers. Everything on the left of our number and everything to the right of our number. Think of any element in the array. Its answer is simply the product of everything before it multiplied by everything after it. We call these prefix and suffix. Let's track our prefix pass from left to right. We initialize our running prefix product to 1. So let's track our prefix passing from left to right. We are initializing our running prefix product to 1. For the first element 1, there are no element to the left. So its prefix is simply our base case, which is 1. For the second element 2, we multiply what we have seen on the left, which is currently 1, by its prefix. So we are tracking prefix over here. So we are seeing 1 and we are trying to multiply its prefix, which gives us 1. For the third element 3, we multiply what we see on the left, which is 2, and we multiply it by its prefix, which is 1. So 2 into 1 gives us 2. And we move on to the last element, which is 4. We see what is on our left, which is 3, and whatever is the prefix, which is 2. So 3 into 2 gives us 6. So our prefix currently read as 1, 1, 2 and 6. Now we do the exact same thing but in the reverse order for our suffix, moving from right all the way to the left. So we reset our running product back to 1 and we will track our suffix from here. So our suffix is going to be 1 to start. So we will start with our last element in the array, which is 4. There is nothing to its right, so its suffix is simply our base case. So our suffix is going to be 1. For the third element 3, we multiply what we just saw on to its right, which is 4, and we multiply by whatever suffix that we have got. So 4 into whatever suffix, we just get 4. Similarly, we move on to the number 2 and we check what we see on its right, which is 3, and whatever suffix that we have. So 4 is the suffix and whatever we have seen in the right is 3. So 4 into 3 is 12. And finally, we come to index 0. So what we see on its right is 2 and what we see here is 12 as suffix. So 2 into 12 is 24 and our final suffix looks like 24, 12, 4 and 11. Look at the magic that happens when we multiply these two prefix and suffix together. We just get our final answer. So 24 into 1 is 24. Again, we multiply our first index of prefix and the first index of suffix, which gives us 12. Again, we multiply 2 into 4, which gives us 8. And finally, when we multiply the last index 6 into 1, which gives us 6, which is the same result. We got our exact answer, 24, 12, 8 and 6 in linear time. Even better, we can optimize this to use zero extra space by storing the running suffix calculation directly inside our final result array. Let's jump into LeetCode. Let's type this out clearly so it runs flawlessly on the first time. First, we allocate our final output result array to match the size of our input array. So I'm declaring an integer variable n where it holds the length of the array, and then we declare our result array. Now let's build our prefix layer directly inside the result array. We set the first element to 1 because there is nothing to the left of the index. Then we loop through forward, applying our pattern of multiplying the previous element by the previous prefix. To do that, we write a for loop where we declare an integer I starting from the first index, and then we go all the way to the nth element. We increment by 1 on every iteration. So what we want to do is we want to compute the prefix at ith position, whatever prefix that we have had before the ith position, into whatever number that we have seen it to its left. That should give us the prefix. So at this point, our result array safely holds all the left product. Now we will loop backwards to apply the suffix layer. We create a running suffix variable initialized to 1, and as we walk backwards, we multiply it straightly into what it's already sitting in our result array. So we are creating an integer variable called suffix, and let's assign it to 1, and let's loop from the backwards. We just create a variable I. We know what is our size of our array. We just do n minus 1 to get the index. We go until the first element, which is the 0th index, and we decrement on every iteration. Now we will compute our result for that ith index. The suffix is nothing but whatever we are seeing on ith index, because our result is holding the prefix already, our prefix into whatever suffix that we have computed. That should be our final result for the nth position. Now we have to update our suffix. So let's update our suffix. So our suffix currently is whatever our current suffix into our current number. This suffix would be iterated on the next loop so that whatever is on the right, it always holds on the suffix, and that's pretty much to it. We just return the result. Now let's run our code. Both of our test cases have passed. Now let's submit this. All the test cases in LeetCode are also passed. Let's wrap this up nicely for the interviewer. Because we only iterated through the array twice in a sequential passes, our time complexity is optimized to a clean linear big O of n. And since the problem statement mentioned that the output array does not count towards auxiliary space, our space complexity is a perfect O of n, a constant space. Splitting arrays scanning into independent left and right passes is a high yield pattern that will unlock a ton of advanced array question for you on an interview day. If you want to practice interactive active recall flashcard built around this prefix suffix pattern on your phone today, so you don't forget it, click on the waiting list link below in the description. Hit like if this visual tracking helped everything click for you, and I will see you tomorrow for the next problem. Let's keep crushing this.